Don't forget to subscribe and turn on notification.
Hello guys, how are you doing? I hope you are doing well. Welcome to our YouTube channel. In the lesson of today, we are going to learn data cleaning from the scratch. I mean how you can be hero from zero in data cleaning, specifically in data science, data mining, and machine learning. Actually, our content of today will have the following parts. Number 1, introduction to data cleaning. Number 2, removing irrelevant vowels. Number 3, handling duplicated vowels. Number 3, handling missing vowels. Number 4, handling outliers. Number 5, converting data types. Number 6, data preprocessing. Number 7, handling typos. And then number 8 is conclusion to our lesson of today. That's it. Number 1, introduction to data cleaning. In the introduction part, we are going to learn the following. A, meaning of data cleaning. B, data validity. C, why do we need data cleaning? Actually, my methodology of teaching is what, why, and how. So, in our introduction part to data cleaning, we are going to learn what is data cleaning and why do we need data cleaning. While in the rest part of our tutorial, we will learn how to do data cleaning. So, I begin with A, meaning of data cleaning. Data cleaning is the process of detecting and removing corrupts or inaccurate record from dataset. That is the meaning of data cleaning. The meaning of data validity. Data validity is the degree to which data vowels, rows, and columns follows the rules of particular requirements in dataset. This means that if you have column of emails, we don't expect it to see phone number, names, or anything else. If there is phone number in column of email, that is invalid dataset, means it should be removed. Actually, invalid data vowels are unneeded and should be cleaned. That is the meaning of data validity. So there is a relation between data cleaning and data validity. We clean data which are invalid and will remain with valid data. That is part B. Part C is why do we need data cleaning? Because it check and remove inaccurate data, incomplete and unreasonable data. This improve the quality of data, hence improve the performance of classifier. So the great intention of doing data cleaning is to have clean data so as we can improve the performance of classifier, or we can improve the performance of algorithm. That is number 2, removing irrelevant vowels. What is this? Actually, we remove rows and columns if they are unwanted. It may happen that you are doing a project, and when doing project, you have recognized that there are unwanted rows and columns. Therefore, you need to remove them or you need to drop. This is the intention of teaching you how to remove irrelevant vowels. Actually, we are going to learn how to remove irrelevant rows and columns. In other words, we can say how to drop rows and columns. So we begin with removing rows. How? We can remove single row but also we can remove multiple rows. We begin with removing single row. Here, let me put comment removing single row. Then I put comment import libraries. Then I start to import pandas as PD. From pandas, import read underscore CSV. Then after, I specify the file path. File name is equal to dataset, then it comments .csv. Then after, data is equal to read underscore CSV. Then I path the file name. After that, I display first 5 rows of our data frame. Actually, this file is located here in dataset. This is my project folder. Then in dataset, there is a file named comments.csv. So I run this cell to see the output. As we can see, this is our dataset. It has 1, 2, 3, 4, 5. It has 5 columns. After loading our dataset, we are going straight forward on how we can drop single row. Right? Let me put comment here, drop single row. Data dot drop bracket name of row, number of row, which is 0. I want to drop row 0. Then axis is equal to 0, means drop from rows. Impress is equal to true. Then data dot head to display first 5 rows in order to see if there are changes. Drop with the function which drop a row. 0 is the number of row. Axis is equal to 0 means drop from rows. Impress true means accept and save the changes. So I run this cell. Now you can see row number 0 is no longer existing. It is already deleted. That is how to delete or how to drop single row in data science. We move to another part, which is dropping multiple rows. I put comment drop multiple rows. Here I specify data dot drop bracket square bracket number of rows to be deleted. Let's say I want to delete row number 1, 3, 4, 5, and 6. Axis is equal to 0. Impress is equal to true. Then after, I display first 5 rows to see the changes of our dataset. After that, I run this cell. Now we can see row number 1, 3, 4, and 5 are already dropped. So that is the first part in removing irrelevant values. We have learned how to delete single row and how to delete multiple rows. We move to the last part of removing irrelevant values, which is removing columns. How? We can remove or we can drop single column, but also we can drop multiple columns. Before we start to drop single and multiple column, let me load another dataset. So file name 1 is equal to dataset, then training.csv. This is a file name I want to load. Then dataset is equal to read underscore csv. Then after I path the file name 1, file name 1. After that I display dataset dot head. I display first 5 rows after loading dataset. Let me run this cell. Now we can see we have successfully loaded our dataset. So after loading our dataset, we are going straight forward on removing single column. So here data.drop, then we specify the name of column. Here it is a dataset. We specify the name of row, the name of column we want to drop. Let's say we want to drop this column. I've copied it, then I paste it in. Axis is equal to 1 means drop from column, then impress is equal to true means save and accept the changes. Dataset dot head to see the changes. Then I run this cell. Now we can see column. This column is already dropped. It is no longer existing. So that is how to drop a single column. We move to our final part in dropping columns, which is dropping multiple columns. Let me copy the name of these columns I want to drop. Let's say we want to drop these 3 columns, right? So here I specify dataset dot drop bracket, then square bracket, single quote, then I paste in the names of columns to be dropped, right? So I separate them like this. Yes. After that, axis is equal to 1, and I will remember that axis is equal to 1 is column, right? Then impress is equal to true. That is dataset dot drop dataset dot head to display the first 5 rows in order to see the changes. Then I run this cell. Oops, what's happening? Let me see. Not found in axis. Axis should be 1. What's wrong? Dataset. Oops, should be like this, right? It should be like this, single quote around. Yes, let's learn once again our cell to see the changes. Now we can see we have successfully deleted these 3 columns. Actually, that is how to remove irrelevant vowels in data science. Number 3, handling duplicated vowels. We can start to learn the meaning of what is duplicates. Let me show you this file. Here you can see these are the rows, right? These are the rows. This row is the origin row, while these 3 rows below duplicates, means they are similar to this. This is the concept behind duplicates in data mining, machine learning, and data science. Actually, duplicate vowels are unwanted and should be handled. Generally, in this third part of our tutorial in data cleaning, we are going to learn how to check if there are missing vowels and how to handle them. Here, let me load a file. I'm loading another data set. So I specify the path, dataset, then breast cancer .csv. Then after, df is equal to read underscore csv. Then I path the file name. Here it should be file name. File name 2. Yes, it should be file name 2. Then I path file name 2. After that, I display first 5 rows of our dataset. Oops, what's happening? df.head. Let me see what is error. Breast cancer does not exist. Breast cancer. Yeah, there is typo error. It is breast cancer. Let me learn this. Now we can see this is our dataset we have loaded. Now we want to check if there are any duplicates in our dataset. So here we write df dot duplicated dot sum, something like this. Then we run this cell. As we can see here, there are 6 rows which are duplicated. That is part number 1 in handling duplicates in data science. After recognizing that we have duplicates, is now the final part of handling. How do we handle duplicates? Is just removing them. So here I can write df.drop underscore duplicates, and then keep first impress is equal to true. Then I run this cell. Now we have successfully dropped the duplicates in our dataset. Let's prove by checking once again if there are still duplicates. Then run this cell. Now we can see there is 0 duplicates. Means we have successfully checked and handled the duplicates. That is how to handle duplicates vowels. Number 4, handling missing vowels. In this part of handling missing vowels, we will do the following. A. Meaning of missing vowels. We'll learn how to fill in missing vowels with 0. That is B. C. We'll learn how to fill missing vowels by using min. And D. We'll learn how to drop missing vowels. So let me start by loading another dataset. Here I'll specify file name. File name should be file name 3, yes. Then after, I specify the path of our dataset, which is in dataset /mauzo 2.csv. Then after, D is equal to read underscore CSV. Then I path file name 3. Then after, I display first 5 rows in dataset, which is data.head, d.head, yes, something like this. Then after, I land this cell. Now we can see these cells indicated by NEA, NAN are the cells with, these are the missing vowels actually. So here we go. We start with ways on how we can handle these missing vowels. Actually, if the data type of missing vowels is integer, you can fill it with 0, you can fill it with min, or you can drop it. But if the missing vowels is object, like name, sex, you just drop it, because you can't know the first name or the last name of a person or the sex. But if a missing vowels is in integer or numeric, you can fill it with 0, you can fill it with min, or you can choose to drop it. That's it. So let me start with how we can fill this cell with 0, right? So here we go. Filling missing vowels with 0. Missing vowels with 0. So here I can do one thing. D, right? Then I specify the name of column I want to fill in. Let's fill this. And A in column called cells in 30 month. Let me copy this. Then I paste it in. Yes. Cells. Then dot fill NA bracket. Then after, I put 0. Impress is equal to true. What's happening? Cells underscore dot fill NA, then a bracket. After that, 0, right? Then impress is equal to true. Impress is equal to true. Yes, something like this. Let's learn this cell to see what's happening. Let's display first 5 rows once again to see if we have successful filled a cell. Now we can see here in cells in 30 months there is 0.0. Before filling in it was NaN. So that is how to fill missing values of data types integer by using 0. Right? Okay, after filling missing values with 0, now we are going to learn how to fill missing val with a min. So what I'll do here, I'll fill these missing vowels, this and this, by using min of this column. So let me first check a min of this column, D single quote, then dot min, and then land this cell. Now we can see the mean of column cells in second month is 287.5, right? So here let's fill these two cells by using a column min. So what we can do here is, let me copy this, right? Let me copy, then paste here, dot fill NA, then after bracket, then after I copy this, copy, I paste it in, then impress is equal to true. It should be like this. Cells in second month should be filled with a mean of cells in second month. Let me learn this cell. Right? So let's display first 5 rows to see if there are changes in our data set. Now we can see cells in second month is filled with the mean cells, right? This one and this one. So in column cells in second month, there are no missing vowels, right? Now we can see. Actually, those are the two ways on how we can fill missing vowels, especially in integer. We have filled missing vowels by 0 and by min. The last way on how to fill missing vowels is to drop. So here, let me drop this cell because it contains missing vowel. How can we do this? Is data dot drop NA, then how NA means that delete any row which contain missing val, right? Then impress is equal to true, right? That's it. After that, let me display first 5 rows to see the changes. Now we can see a cell with missing val is already dropped. So row number 3 is dropped. Here we don't have row number 3. Actually, now you can see that there is no missing val, right? If we try to check missing vowels, we can see we have no longer that d dot is null dot sum. Now you can see 0, 0, 0 means that in this column there are 0 missing vowels. So that is how we can handle missing vowels in data science. Number 5, Handling outliers. Actually, in this part of handling outliers, we are going to cover two subparts. Number one, meaning of outliers. Number two, how to check outliers using z-score. And how to remove outliers, right? So we start with the meaning of outliers. Outliers is an object that deviates much from others. Generally, observation which deviates so much from other observation, it arouses suspicion. It was generated by different mechanism. So that's the meaning of outliers. How can we check outliers? By using z-score. Before we carry on checking how to detect outliers, let me load another dataset. Right? Let me load another dataset. This is actually our fourth dataset. So let me write name, file name 4 is equal to dataset, then bootcamp.csv. Then after more is equal to read underscore csv. Then I path the file name. It should be 4. For file name. This is the 3, so it should be 4. Right? So let me put 4 here, and here file name 4. Then after more dot head to see first 5 rows. Now we can see this is our data set, and our intention is to check for outliers by using z-score. Generally, we are going to check on a specific column called age. We want to see if there is any outlier in column age. So let me select a column age. Let me x is equal to more, then age. After that, let me display first 5 rows of column age. Let me run this cell. Now we can see that we have selected column age and stored in variable x. After that, we are going straight forward to check outliers. So from scipy import stats, import numpy as np, right? Then after importing, we are going to define a threshold. Threshold is like a limit. Let's set a limit that no human being can have 500 years, right? Then after, I put here z is equal to np.abc, then a bracket, stats dot z score, then I path x, right? It should be something like this. Then after, I want to print np dot where bracket x is greater than threshold, right? Something like this. Let me run this cell to see. Now we can see our zero score method have detected that row number 0 and row number 5 have outliers. Let me clear display first 10 rows. Now we can see here this a person in row number 0 have 2000 years, and a person in row number 5 have 2500 years. Actually, this is outliers. Can human being have 2000 years or 2500 years in this current world? This is wrong. So that is how we can check the presence of outliers by using zero score. After that, we can handle outliers by either removing them. Just removing, drop them. So here we can do something like this: data dot drop, then I put a bracket 0 5 axis is equal to 0, then impress is equal to true. Then after I line this cell, after that more dot head, now we can see row number 0 and row number 5 are already dropped because we detected them as outliers. So that is how we can handle outliers in data science. Number 6, converting data types. Actually, in this part, we are going to learn how we can convert object data types to integers. As you can see here in a column rate, these are the words, objects. So we need to convert them into integers, right? Here, if I put d.d types, we can see that these are the floats while this is object. So we need to convert this from object to integer, right? So here, before we do the actual action of converting, let me do feature selection. Let me do something, feature selection. Here, let me set x is equal to d dot ilog. Then after number 3, y is equal to d dot ilog -1. Then let me display first 5 rows of x. Now we can see x containing rate, cells in the first month and cells in second month, right? So after that, we are going to convert these fields in column rate into numbers. So before we do that, we need to create Python dictionary words, which will help us to map between word into number. So words to number, word to numbers, then I path like a parameter. Then after my dict, this is my dictionary, right? So it should be something like this. Then I paste in something like this. So our dictionary contain 1 to up to 12, right? So whenever there is one of words it will fill in with one of number. That is, yes. Then after return my dictionary, then something like this. Let's learn this cell. I hope no error. Then after we have created Python function, which inside there is a dictionary which will help us to map words to number. After that, we need to use apply and lambda to convert words into number. Then I'll do something like this. X red, let me see, head. Now we can see these are the words 2, 6, and so on. So here let's do something like this. Then rate is equal to x rate dot apply, right? After that, lambda x, then words underscore 2 numbers, then we path x. Let me see if this is function words to numbers. This is words to number. It is to number, something like this. Then after, let's run this cell to see what can happen. Actually no error. If we try to check, yes, red dot head, we can see now we have successfully converted these. Before, at the beginning we had words 2, 6, 4, 7, 5. Now we have numbers 2, 6, 7, 5, and so on. So actually that is how we can convert words into numbers, especially if you have given a column which contain words in numbers. Number 7, data preprocessing. Actually, in this part, we are going to learn how we can process categorical data into numeric. Here, I'll load the dataset, file name, let me put 5 is equal to dataset slash categorical dot csv. Then after, data frame is equal to read underscore csv, then file name 5. After that, data frame dot head see first 5 rows. Now we can see actually this is how data in categorical form looks like. You can see this is a range, 40 to 49, 15 to 19. That's it. So we are going to use label encoder in order to preprocess categorical data types into numeric, right? So here from sklen import preprocessing from sklen dot preprocessing import label encoder. Let me run this cell. Now we have successfully imported. Then after, I'm going to create a function called the categorical transform underscore transform. Then I path. Let me copy. Yes, here. Copy. Then I paste in. It pass data frame. Then after, LE is equal to preprocessing dot label encoder encoder, something like this. Then after here, I'll paste the data frame, right? So data frame dot the name of column data frame dot age is equal to le dot fit transform, then bracket, I copy this, copy and paste it in, something like this. Then after here, I need to, let me copy this once again, copy, then I paste here down. After that, I copy the name of this column. We want also to convert it from categorical to numeric. So I'll remove this. Then I paste here, term size, and then here, term size. After that, I align this cell. Then after, I call this function here. I call this function. So let's just copy it. Then I paste it here, right? After that, run this cell. Then after, let me display first 5 rows data frame dot head to see if we have successful. Now we can see column age is in numbers now. Column term size is in numbers, means we have preprocessed it from categorical to numeric format. That is how to do data preprocessing, specifically converting or preprocessing categorical data by using label encoder. Number 8, handling typos. Actually, typos are the incorrect spelling. I mean, when we say typos, we specifically mean that it is incorrect typing of spelling. Actually, in machine learning, we don't frequently use this method of handling typos. As you can see, this column, there is typos. Here it should be female. This letter should be removed. In machine learning, we can remove typos manually, but in natural language processing, there are different ways they use to handle typos, like deletion, transposition, replacement, and insertion. Here, as you can see, we can correct this, right? So let me go in our dataset, bootcamp. Here there is a female. It should be something like this, female. Then Control S to save the changes. Then after, I can, let me, oops. Yeah, but if you run this cell or you load once again this cell, changes will be reflected. So that is how to handle typos. Mostly it is being done in natural language pre-processing. Actually, that is an end of our lesson of today. Just to remind you of what we covered from the beginning of this lesson up to the end, we started with introduction to data cleaning. We learned removing irrelevant vowels, handling duplicated vowels, handling missing vowels, handling outliers, converting data types, data preprocessing, handling typos, and this is conclusion. Actually, I've enjoyed a lot. I don't know if you have enjoyed, but if you have enjoyed this lesson, let me know. Put comment below that enjoyed. If you have enjoyed, put comment that I've enjoyed. Also, if you have not enjoyed, put comment that not enjoyed. Thanks a lot. Check below video description. There is a link to GitHub and download the repository which contain this Jupyter notebook I've used and oral dataset. Thanks for watching. Do not forget to like if this video is good, put comment if this video is good, share if this video is good, also subscribe for next video update. Thank you. See you in the next videos.
Please don't forget to subscribe and turn on notification.